Yes, good evening all. Uh, you can see my screen, right? Guys, can you one of you confirm? Uh, you're able to see my screen, right?
Yes, sir.
Okay. Uh, I think there is a 1 week delay for the second episode continuation. So the last week I have some family emergencies, so I couldn't make a session. I think I'll resume the things from where we stop. Hope you remember on this episode 2. The major contribution were, the Java 8 concepts I have taken. As part of the Java 8, I hope you remember the first three concepts, buddy, we covered in the last week. The first thing, the features of Java 8, and then Lambda expressions, how to write Lambda expression from scratch, I have shown you. Also have explained how to use consumer supply predicate and functional interfaces. And these three concepts were based to understand rest of all concepts in Java 8. So we'll start, buddy, the first one today. The difference between the first question, maybe we can see the difference between for each loop and a for each method. So, and for each problem, I mean, for each question, buddy, I'll explain you today with programming, the difference between for and, the for each. First, we'll see. And I think this is what the slides, yeah, this is what the differences first you should know. First, what I'll do is I'll take you a normal for loop, how it will work. Normal for loop, how it will work. So I hope you can see the Eclipse now. Now, guys, can you see the line number 6? I have created an array. I have created an array. So if you want to, if you want to access each element from this for loop, I mean, from this array A, then you have to take a ordinary loop called something, for loop. So I think everyone pretty good with the for loop syntax. So first we have to declare the starting index, that's a int I equal to 0. And then you should say I less than a dot length, so it will refer condition. And then you have to increment every time by 1. Okay. And then finally, guys, you can write a of I, right? So that you can see each element on the screen. Each element on the screen. See, this is what how to access element by element. Now this is for loop, right? And there is a advanced for loop concept is also there. Advanced for loop concepts also there. So the advanced for loop has a minimized syntax compared to the for loop. Compared to the for loop. So in for loop, what you're doing? The first you are doing initialization part, then condition part, right? Then increment part. But if it is an advanced for loop, just what you need to do is, yeah, I'll give you some hints to you to remember. I'll just, give you some hints, the steps to you to remember. First, what you do is, as it is used, you have to use a keyword for, and inside the parenthesis, first put a colon right side, you can write your array name, colon right side, you can write your array name, and colon left side, you can write, you can write, you can write type of the array, you can write the type of the array, and one singular element you have to declare. Let's say the variable name is something, x. Now what this x will do is, x will take each element from this array. No matter, no matter, this array has one element or 100 element or 1000 element. So x will take each element from this array and will print on the console. Will print on the console. So this is what how we can use a advanced for loop. And this is also called as for each loop. This is also called as for each loop. You know why it is called as for each loop? Because from the array, each element assigned to A, each element assigned to A, I mean, sorry, X, and that X value we can access inside this loop. And if you see the advantage of the for each body, here we are not declaring any initialization and condition part or increment decrement part like how you are doing for the for loop. Simply, you should declare array name, and left side of the the colon, you have to just declare the type of the array and some singular variable name. Singular variable name. Now, also if you run this code, you can see the same output, buddy. Same output. So if you see, we have running the code twice, right? I mean, on the top you can see normal for loop will printing 1 to 6, and then the second, if you see, for each loop will printing 1 to 6. This is normal for each loop. If you go back to the question is what they are asking, the difference between for each loop and for each method. For each loop and for each method. Now I have explained you, buddy, for each loop. For each loop. Now the question is what for each method. Now let me explain you what is again the for each method. We discussed for loop, right? I mean for each loop, right? Now I'll discuss you about the difference between for each loop and a for each method. Is it clear first? Guys, confirm in the chat. The difference between normal for loop and a for each loop. Is that clear? Okay. Okay, good. Now let me take you the difference between the for each loop and the for each method. Guys, now if you see line number 9, I have created a array list. I have created array list and have added 5 elements. I have added the 5 elements. This is collections, right? Not array. It's a collections. Earlier example is arrays, right? This example is collections. Now I have taken a array list which has 5 elements. Now, if you want to access each element from this, then Fuddy, I'll show you how to access by using for each loop first. For each loop first. As usual, the syntax. So I told you the syntax. So first write for as this, put the colon. Colon right side, what you have to write your collection name, like how you did array name in the previous example. Okay, so here you have to write your collection name. So your collection name is integers. On the left side, right, you have to declare the type of this collection. So the type of the collection is integer. Okay, and you have to write a singular variable name. Guys, if you still get confused what is singular variable name, if you have a 10 pens in your hand, 10 pens, right? You should call it as pens, not pen, correct? So pens is a plural, pen is a singular, correct now? So that's what actually I was using the word here. Singular name you have to use it, because if you see line number 10, the collection name itself I have given plural, see, integers, because my intention is I want to store multiple integers. And from multiple integers, I have to take each integer. So that's the reason I have given a variable name as singular variable name. See, singular variable name. Okay, okay. So now you can print body. Now you can see element by element. So instead of writing this comment, I'll show you this way. So now if you run it by using for each loop, we are accessing element by element from the collection. Element by element from the collection. Yeah, you can see. Right? Actually, still we are not entered into the the main question. The question is now the difference between for each loop and for each method. Now we discuss for each loop now in collections. In collection. Now it's time to discuss for each method. Actually, for each method is introduced in Java 8. For each method is introduced in Java 8. So it's a method. So for each is a method now. It's a method and it is introduced in Java 8. Now the purpose of this for each method is see how much code we written. See how much code we written here. So to minimize the code of for each loop, yeah, we are going for for each method. Actually, for each method will take the argument as consumer functional interface. Okay. Now let's see how to call this. This also will do the same thing. It will take each element from the collection and return it. Let's say this, how to do that. So the steps very simple, buddy. Write your collection name and call the for each method. Call the for each method. Now if you hold the control key and go to the for each method definition. Now can you see it is introduced in 1.8. 1.8. Okay. and it is taking, consumer a functional interface, consumer functional interface, right? So I'll tell you about how, the method it's going to be implemented. And if you want to know what the consumer interface, again hold the control key and go to the consumer interface. Now, can you see this method? The consumer interface has only one method, the abstract method. The method name is accept. So what it will do? It will take the it will take one object. It will take one object, and if you want to perform any operation on that, we can perform it. So I'll write it body here. If you see, I hope you remember the shortcut to write, functional interfaces. That is lambda expressions. PAF is a shortcut. I hope you remember PAF. So we should write parenthesis, then arrow, then flower basis, PAF. And now, as I told you, it will take single argument. So we can take element is an argument or integer is an argument. And inside the flower basis, I was just printing that element. I was just, printing that element. I was just, printing that element. Sorry, this is, let me take the variable ml properly. Yeah, integer. The variable name is integer. So that integer, as it is, I was printing it here. And I hope you remember, if it is a arrow functions or a lambda expression, if it has a single parameter, parentheses are optional. And if it is a single line statement, then the flower base is also optional. Flower base is also optional. Flower base is also optional, right? So you can remove the flower bases, can remove the flower bases, and you can write it. So this is, how to write single line, single line, single line, your lambda expressions. Run it, and guys, you can also see the same out. So I want to just highlight one point. For each is a method which is introduced in Java 8, and it is more user-friendly compared to your for each loop. It will take the argument as consumer functional interfaces. So this is how to write the code for the for each method. Does that make sense? What is for each method will do? Guys, can I get an acknowledgement? Hello. Guys, is it clear the difference between for each loop and a for each method? Okay. Okay, good. And yeah, so these are the syntaxes which I have written in the slide. So on the down, you can see the syntax of for each loop syntax. And the next slide, if you see the for each method, the syntax. See, the for each method was introduced in Java, and it provides a way to iterate over elements of a collection. And it takes the consumer functional interfaces. Just now I have given in the example. Now let me jump to the very important question from Java 8 is, what is use of optional class? Okay, I'll go with from scratch, but again, what is optional class and all? First, you should know the basic example. First, you should know the basic example. Now, if you see, I created one string. The string value is such a, okay, and the variable name I have taken as name. I mean, the object name I have taken as name. Now, if I do name dot to uppercase, I hope you guess the output, right? The output will be Sachin. The output will be Sachin. Before we moving further things, buddy, can you see here? String is a ready-made class, right? String is a ready-made class from java.lang package. You can hold the control key and go to, it's a definition. So string is a class. String is a class, and come back. And the two uppercase is one instance method. So you can hold the control key and go its implementation. So, but if you see, it's a instance method. I mean, there is no static keyword. So these methods are accessed by object name. Now, line number 6, what you did? You created an object with new keyword. You created an object with new keyword, and you are calling the two uppercase so that you can see the Sachin as the output. So let's run this. Let's run this, and you can see the output, buddy. It's a Sachin, right? I think this example is straightforward, right? It's not going to be making you any confusion, I believe. Now in the same example, now what I'll do is instead of new keyword, I was writing null. Okay, instead of new keyword, I was writing null. So let me keep that code as it is. Let me comment that code. Yeah, the second scenario, buddy, I was showing I was assigning with null. First, you should know the meaning of null. New means a new memory is created. New means a new memory is created. Null means no memory is created. So the point you need to understand, null means no memory is created for name object. Name object, but the name is an object name. Okay, no memory is created for name object. In terms of C language, a memories are called as something, pointer. In C language terminology, we can call it as, pointer. So no, there is no pointer. There is no pointer for the name. Okay. Right. Now, can you see line number 9? You can see the warning actually, yellow color line. Maybe I'll zoom it. You can also see line number 9. Here you can see a warning. And I'm damn sure if you are a fresher, you cannot concentrate on the warnings. But if you enable some tool called, code quality checkers, like a sonar cube, okay, so it will show, it's a big issue with this line number 9. This line number 9 is not going to be passed if it is, good code. So you can see the warning. If you place a cursor there, you can see a warning here. If you see the warning here, read the error. So it's saying that null pointer access. Yeah, line number 8 I have explained, right? Null means no memory, no pointer. And if there is no pointer, how are you supposed to access this method? You cannot access it. If a full object is created with new keyword, right, then only we can call that methods. Null means no memory, no pointer. So if any object has null reference, and if you try to call inside it methods, then you'll get, null pointer exception now. So earlier program will be, Sachin, you will get it. But now if you run it, you'll get, null pointer exception. You'll get, a null pointer exception. So this is what null pointer exception is going to be getting. I hope now you are clear what I mean by null pointer, null pointer. And don't get confused, sir. We can also create the strings without using new keyword. No, like this, right? I think you are suspecting this, right? But both are same actually. This line and this line, both are same. And the memory allocation is differ in string pool. Okay, string pool, but a memory is allocated for this as well. Inside the JVM, a memory is created for this and as well as this also. Okay, that's again a different concept, string pool. But let me focus on something, null. I mean, null and a new keyword. Internally here also a new keyword is definitely used. Internally here also. Okay, don't get confused. Here there is no new keyword, so there is no memory. Yeah, without new keyword also a memory is allocated inside the pool area. Okay, so just let me concentrate on null. New means new memory is allocated. Null means no memory is allocated. If there is no memory, you cannot access inside the methods. You cannot access the string class methods. If you try to access it, you'll get null pointer exception. Now let's back to the question. The question is optional class. Now this optional class, yeah, now read the definition. But this optional class introduced in Java 8, Java 8 from java.util package. And what it will do here is it will check whether the object is null or not. Yeah, this class duty is check whether the object is null or not null. That is, the main purpose of this class. Okay. I'll explain you, buddy, before optional class, how we are dealing with this null pointer exception. And with optional, how we are dealing also, I'll show you. Okay. So this is an example, and I hope you are clear. Now, guys, I have taken one more example here. Yeah, there's a person class I have taken. Person, general class. And a person has a one member called, the person name. And here you can see, a constructor to assign the value for the person. And you have a getter to get the person name. And but there are two business methods I have written. Yeah, they are very simple business methods, easily can understand. A person, yeah, generally will do eating, right? A person will generally do sleeping, right? So I have written some messages. See, the person name, yeah, love to eat some item, and this guy, love to eat. Love to sleep this many hours per day. Okay, these are some methods. I want to repeat this again. One data, and a constructor used to initialize the data to for this name, and getter used to get the name which is assigned by the constructor. And there are two methods, eating and sleeping. Okay. Now let's jump to the coding part. Now line number 6, if you see, I created an object for the person class. Okay. I created an object. I created an object. Okay. New person of Sachin. Now what I was doing line number 9, I was calling object.getName, object.getName, nothing but Sachin will come, and uppercase is nothing but, yeah, it definitely, it convert into uppercase. It will convert into uppercase. See, we are getting Sachin, right? So this is the previous, similarly, previous example. Now, if I call, if I call person dot, now if I call person dot eating, let's say eating, and I was writing, the item is biryani. Item is something, biryani. And let's call one more business method, sleeping, right? Person one dot. Let's call a method sleeping, and let's say 8. Now let's run the code, and you can see three outputs here. Three outputs here. One is Sachin in uppercase. Next is Sachin love to eat biryani, and Sachin love to sleep, 8 hours per day, right? Now let's keep this example as it is. I think there is no doubt here, I believe, everyone. Now, if you see, guys, now if you see, same code, same code, same code, if you see. Now what I was doing line number 5, I was not creating the Sachin, person object. I just given null. I just given, null. I just given, null. Now what I was doing line number 7 and 8, there is no object is created, and I was calling even the previous line also, where you will get that exception. Yeah, from line number 6, you will get the exception, right? And null pointer exception. Here also you'll get the exception. Here also you'll get the exception. Yeah, you may run it, and definitely you can see null pointer exception. Null pointer exception. See, you're going to be getting, a null pointer exception. Now, how to handle it? How to handle it? How to handle it? So actually, before optional class, we have to check like this: if person is not equal to null, right? Then we can able to perform this operations. We can able to perform this operation. All operations we can do it. We can perform, all operations. Otherwise, we will not do any operations. Now, if you run the code, since the object is null, since the object is null, this condition is false. So the control comes to else, and the else part we haven't written. So nothing it is doing. Nothing is doing. But let's say if you created an object like this, if you created a full object like this with new keyword, with new keyword. Now this condition will become true, right? Okay, because the person is not equal to null, and yeah, you can able to perform all these operations. Okay, this is how we are doing with null keyword. But the optional class introduced to make to do null check buddy, we use the optional keyword. And same code I'll write by using optional class. If you see here, same code I'll write it. Let me comment that code. Let me comment that code. Let me comment that code. Yeah, let me comment that code. Yeah, now this code I'll write by using optional class C. You should say optional. You should say optional dot. You should say optional dot of nullable of your person object, and dot you can call is present, is present, is present. I think this is the person one. Sorry, person one. Now, buddy, this is also doing the same. This is also will doing the same work. See the code optional dot. There's a method called of nullable. So what this method will do is hold the control key, hold the control key, and go inside this method. So what this method will do is, can you see, buddy, what it is doing? It is taking your person object, and it is checking, buddy, where it is null or not. If it is null, it return the empty object. If your person object is null, it return a optional empty object. Otherwise, buddy, it will return your person object. It will return your person object. So internally, that's what happening when you do off nullable. And what is present will do here is this is present. Yeah, again, go inside this method and see it's checking your object is not equal to null or. So if it is not equal to null, we are able to perform this all operation as usual. Let's run and you can check it, same output we are getting. Yeah, I know this is a little bit complex to you to understand here. What is optional class, but it is, replacement of your null check. It is, a replacement of your null check, null check, null check. So always in real time, we'll check whether the object is null or not. If it is not null only, we can able to perform this operation. Otherwise, buddy, will not do any operations on it. Okay. And if you get a time, buddy, please try to, refer this methods. Okay. Please try to reverse, this methods from the optional class. Okay. Because I just given an introduction. I just, introduction part. I just, given a introduction part. But if you really want to learn more, yeah, please, go through these methods, go through, the 7 methods. So you can understand much better. I think you got the clarity, why optional class introduced in Java. Make sense? Guys, does that make sense? Hello? Yeah. Okay, cool. I just give an intro, but the main purpose I think I have delivered to you, right? But yeah, you have to know this methods as well, what empty method will do. Generally, empty method will return an empty optional object. And off method, if you are sure that your object is not going to be returning any null, then you can use off. And if you're not sure your object may return null or may not return null, then you have to go with off nullable. And these present method will work, if the object is not null, right? Then we can do some subsequent operation. Then we'll go with is present. Get method return the current object, and or else method will, if your object is not there, like what if any default work you want to do, then you have to go with or else. And if there is a null and if you want to throw any custom exception, right, then you have to go with or else throw method. Just, high level one line statements have given, but definitely you should see some examples on this method. In just Google type how to use empty method from optional class, how to use off method from optional class. You may get examples, but just go through that. And that's all about, your optional. Okay. And yeah, these are some key points. And yeah, just now I discussed you this methods: is present, is empty, or else get. Okay. And yeah, anyhow, our upcoming concepts also you can learn what is map and float map as well. Okay. So these are some bullet points that you to remember about, the optional class. Maybe you can spend some time on it later. And yeah, next question, buddy. Let me go with something, actually in Java 8, the biggest change in Java 8 is among all the versions is stream API, right? And the stable version of Java, Java 8, Java 11, 17, and 21. Before Java 8, there are a lot of versions are there, right? I mean, 1, 2, 3, 4, 5, 6, 7. But Java 8, the biggest change is stream API in collections. Now, I'll try to go with an example of collection, right? And then I'll show you, buddy, what is the use of stream API on top of the collections. Because the question, if you see, what is stream API and how it is differ from the collections. So what I'll do is I'll take one collection example first. On top of it, I'll show you the need of stream API. Now, if you see, I have taken one example here. Yeah, I have taken one collection example. Yeah, this is a collection example. So I have taken an array list. I have taken an array list with 10 elements. I have taken a array list with 10 elements, 10 elements. And now the requirement, if you see, I want to create a new list. I want to create a new list with even numbers. This is our requirement. So let's try to, achieve this requirement by using collections. But later I'll show you how to achieve the same thing by using stream API. Let me keep this code copy. Okay. First, I'll go with, using collection. And the next, buddy, I'll show, stream API. And I'm pretty sure at the end, you can see what is, the main difference of collections. I mean, stream API. So let's see how to do with the collections. This is your original collection, right? Numbers. Now you need a new collection. Now you need a new collection with even numbers. with, even numbers. So what I'll do is I'll create an array list. Okay, I'll create one array list of with integers, with, integers, and which can store only, even numbers, even numbers. So first thing you need to do this. You have to create an empty collection. You need to create an empty collection like this. New array list. New array list. Yeah, like this. What you have to create an empty array list. I'll tell you how to fill the even elements there. Okay, this is an empty array list. First, you created an empty array list. Now, what we need to do here is with the for each loop. Hope you remember. Just now we learn what is for each. For each loop. For each loop. So what I was doing with for each, colon right side, I was taking your collection name, right? And colon left side, I was taking, collection type and a singular variable name. Now in the singular variable, each integer will come, right? Each integer will come. Now what I'll do is, I was checking one condition, the even condition. If your integer mod 2 is equal to 0, right? Because the logic is this one, right? Even numbers. If your each integer, if it is divisible by 2, then you know what I was doing. For this new empty collection, I was adding the this integer. This integer I was adding. Okay, let me check. Yeah, I think the variable name has replaced. Sorry. Yeah. Guys, I want to repeat this again. See what for each is doing here is it is taking each element from this your original array, original collection. And what you're doing, we are taking each object here, each element, and we are checking the even condition. If it is true, then for this empty collection, we are adding the elements. Right? After doing this all, if you print even numbers, okay, if you print even numbers, right? Even numbers now you can see only the even collection. You can see but the even collection 2, 4, 6, right? Is this code is clear? How to get even numbers from your collection? This is a using collections. Is that clear? This guys, confirm in the chat. Before we go into the stream API, we should know the complexity of the collection. This is collections concept. Make sense? Okay. Now let's see how do we customize this code by using stream API. How we can customize this code by using stream API. Same code. Let's say now in streams, what we can do. Actually, every time I'm using the word original collection. So this is your original collection, right? Here also this is your original collection. Now what stream will do is stream will not modify your original collection. Stream will not modify your original collection. Okay, that's the first thing you need to understand. So just you need to call a method called something stream. You need to call a method called something stream. You need to call a method called some stream. So when you call stream method, all your collection elements will be move into the stream. So the stream is nothing but a flow of data. Streaming is nothing but generally flow of data. Actually, the advantage of stream API is you need not to worry about internally how methods are working. As a beginner, but understand some term filter. Understand some term filter. Now stream dot, I was calling a method called something filter. Now filter will take each number. Filter will take each integer from there. And but here you can pass a condition. The condition is integer mod 2 is equal to 0. So what this filter will do is it will pass this, it will perform this test. Filter will perform this test on each integer from this numbers on each integer, and the elements which are passed, that elements will be written by this filter. Now at the end, what you need to do here is filter. You need to call a method called something collect. Because after filtering, 2, 4, 6, 8, 10 will come. After filtering, 2, 4, 6, 8, 10 will come. But the 2, 4, 6, 8, 10, you have to store into a new list, right? You have to store into a new list. For that purpose, buddy, you have to call a method called collect. You have to call a method called collect. So what collect will do is it collect the 2, 4, 6, 8. It will collect the 2, 4, 6, 8, 10 elements. And then what collect will do is move this 2468 into a new array list. If you want to create a new array list, inside the collect method, you have to call you have to call you have to call collectors dot you have to call collectors dot collect the dot. You need to call a method. The method name is something, to list method. You have to call it to list method. You have to call it because collect method is getting 2, 4, 6, 8, 10. The 2, 4, 6, 8, 10 methods converting into the new array list. Now at the end of the semicolon, if you do a shortcut Alt Shift L, okay, you will get it will ask you, what is the name of the variable now you want to keep. Then you can write something, even even numbers as new collection name. That's all, buddy. You need to do it. That's all you need to do it. Yeah. Now if you print it, if you print it, if you print it, now you can see your even numbers. Now you can see your numbers 2, 4, 6, 8, 10. This is something, the advantages of this is something, advantage of your stream API. Your advantage of your stream API. 1 second. I want to show you some operations here. 1 second. Yeah. I'll show you what's happening on each step here. Yeah. Now, if you see the first step, what's happening here? The first step, what's happening. Yeah. So this is your original collection. Now, what stream will do? It will take your complete original collection as a stream. And the first step, what you are doing? We are doing filtering. After streaming, we are doing filtering. After filtering, what filter is doing? It is testing this condition on each element. After that, after filtering, you are collecting the elements. You are collecting the elements. After collecting the element, you are creating a new array list. That new array list elements will be stored into, in a even numbers. That's what, how it is working. That's what, how it is working. Here, few things I want to highlight you here. Few things I want to highlight here. Now, can you see here, filter? Actually, what filter is doing? It is performing some testing on your collection. Filter performing some operation on your collection. Now, what collect is doing? Collect, preparing the final response. Filter is doing a intermediate operation. Filter is doing an intermediate operation. Let me write that word, intermediate. It is doing an intermediate operation. And what collect is doing? Collect is doing a final response, right? That is technically we have to call it as something, terminate operations. So there are two technical terms we use throughout the Stream API. There are two technical terms we use throughout the Stream API: intermediate operations and terminal operations. Intermediate operation and terminal operation. Intermediate operation, nothing but in middle with your collection. If you want to perform any operations, then you can say that is intermediate operations. And if you want to prepare a final response on top of your operation, then that operations we have to call it terminate. So collect is doing your kind of terminal operation. Filter is doing, kind of intermediate operations. So that's all, on high level, what Stream API is doing, what Stream API is doing. And one more point also I want to introduce here. One more point also I want to introduce here. You see here, first you have taken a number and you are putting dot, correct? And you are putting dot here. Focus on the dot. Number dot stream. Then stream dot filter. And then filter dot collect. And then collector dot to list. See, buddy, how many dots you are using? Numbers dot stream dot filter, filter dot collect, and collectors dot to list. So this all dots we are connecting and we are preparing finally, a even numbers, right? Finally, we are connecting all the dots. This is actually we have to call it as a pipeline operations. This is actually on a high level. we have to call it something, pipeline operations. Let's say, buddy, what am I pipeline operation? Let's say general scenario. I was talking about a general scenario. What am I pipeline operation? Let's say here you have a uh, plain water. Here you have a plain water. You have a plain water, and there's a pipe, red color pipe. There's a pipe, red color pipe. And from the red color pipe, if you move that, the water, then definitely the water will become, in red color, right? So this is something, pipeline operation. So what is pipe is doing? It is converting your plain water into red color. Similarly, on this dots also, if you see on each dot operation, one operation you can see on each dot. And in real-time coding also, you can see multiple dots. So before dot, a method is called, and the method will do some operation on that original collection object. Now, maybe I can show you the slide so that you can understand the better points. So if you see now, the Stream API introduced in Java 8 that follows a functional style or sequence of elements. Sequence of elements. 1 second. Yeah, and we can perform easily operation on your collections. And buddy, these are the 4 bullet points you can remember on the Stream API. The first one is, if you see, declarative processing. Declarative processing is nothing but let's see this definition. Streams allow for declarative processing of elements, where you specify the what operation you want to perform on the elements without specifying how those operations should be implemented. Read this word again. Let previous example, if you see filter, really you don't know what filter is doing, correct? And really you don't know what collect is doing in the previous example, right? But on high level, you understand by seeing the example. Filter passing some condition, and if whatever the values are passed in the condition, collect is picking that elements. That's what actually the declarative processing. Even you don't know what the methods are internally doing, you can write that methods in a sequence and you will get the final output. That's what they're telling on declarative processing. Now, can you see lazy evaluation? Actually, lazy evaluation, nothing but if you see in the previous example, what filter is doing? Filter performing some operation on the each element, right? And it's an intermediate operation. So what filter will do is, filter will do this operation and will not store the final result anywhere. Will not store the final result anywhere until unless if you call the collect. So if you call collect only, the final response will be prepared. So then we can say filter is, a kind of, lazy operation it is doing. Now we can see stream operations are typically lazy. Stream operations are typically lazy, meaning that intermediate operations like filter, I just now shown you filter, are not evaluated until a terminal operation, a terminal operation is invoked. Terminal operation nothing but I just now shown you, right? Collect. Okay. And if you see pipeline, I shown you dots. I shown you something, dots. Now read the point, you can understand. Stream supports method chaining. Stream support method chaining. Yeah, method chaining is nothing but I just called, numbers dot stream, stream dot filter, filter dot collect, right? Again, collectors dot to list. That's all, the method chaining, right? Definitely the method chaining will give, the final response. And also the last point, I haven't discussed this, parallel processing. Actually, parallel processing is nothing but let's imagine, imagine you have 1,000 employee objects, 1,000 employee objects. Now, with the help of stream, you want to check whether an employee eligible for bonus or not, and there I have written one condition, their salary below 40,000. If they're below 40,000 only, they are eligible for bonus. Let's say this is a scenario. Now, if it is a stream API, if it is a normal stream API, what stream will do is it will go to the first object and check whether the first employee is eligible for bonus or not. After that, it will go to the second object for checking eligible for bonus or not. Like that, it will go for 1,000 objects per day. Let's say 1 lakh employees are there. Yeah, one after another, it will go and verify 1 lakh employees. And definitely, very biggest process, right? Yeah, 1 lakh times, the stream has to check whether the employee, eligible for bonus or not. Now, if you go with the parallel processing, no, if you go with the parallel processing, that 1 lakh employee objects at a time we can check instead of going object by object, that 1 lakh objects at a time we can check whether the objects are eligible for bonus or not. So inside it we can use multi-threading. Inside it internally we use multi-threading inside the parallel processing. So that's what's the use of stream API. And this all operations, but you cannot see in collection. That's the reason they introduced stream API. Okay. So yeah. Now if you see the second next question, actually this question is more give you the clarity on the previous question only. Because I told you your complete Java stream API is depend on two types of operation: intermediate operation and terminal operations. Now, but you can see this slide. In the context of Java streams, all operations can be classified into two categories. Yeah, all operations in Java stream API, all operations are catered into two types: intermediate operations, terminal operations. Guys, are you clear the difference between intermediate operation and terminal operation in this example? I want to hear an acknowledgement. Are you clear the intermediate operation and terminal operation? Any one of you confirm in the chat? Okay. And now let's see what other intermediate and terminal operations. So I think I have discussed them in my previous sessions. I remember I have discussed them. The filter map reduce. Okay. And maybe I can give on high level example what map and a filter and sorted distinct will do here as intermediate operations. Maybe I'll quickly jump to the Eclipse and I'll show you the example. Yeah, first we'll see something map. Let me take a requirement here. What map? The requirement first. I want to do square of each number. I want to do square of each number. Okay. Then the code goes I mean, what we are doing, we are modifying each element, right? Then we have to go with a concept called map. If you want to modify each object, in the collection, then you have to go with a concept called map. So I'll show you how to use the map now. I'll show you how to use a map now. Numbers dot stream. Okay, number dot stream, and you have to call a function called map, and each element will come here as an argument. Okay. And arrow symbol, you need to do element times element. Nothing but you decided to do square of each element, and this intermediate operation, right? This intermediate operation, and we know the final result is 1 square, 2 square is 4, 3 square is 9, and 4 square is 16. But to collect the elements, then you have to do collect dot. You have to say collectors dot to list. You have to call it so that again what collect is doing. It is a terminal operation. It is intermediate operation. And it is a terminal operation. Terminal operation will return the final result. So do Alt Shift L. So you will get a result 1. So I was taking a variable name as result 1. So if you print in result 1, in result 1, yeah, you can see square of each element. So you can see square of each element. Square of each element. That's what what map will do. And filter body just now we discussed. I don't want to repeat that again. Just now we discussed it. Now let's go with something sorted. Now what I'll do, buddy, let's take this element something random order like this. Let's take this elements in random order. Now they are some random order. Now if you want to sort them, directly, what you can do, numbers dot stream, and directly, buddy, you can call something sorted. Directly you can call something sorted. Sorted means yeah, the values will be sorted, but final result is still not at map. Final result, you are not storing this result in any variable. If you want to store any variable, again you need to take the help of collector. That is terminal operation. Definitely you have to take the help of terminal operation. Now you can store that into another variable as a result, And finally you can print the result so that you can see you can see you can see the elements in you can see the elements in ascending order. Now you can see the elements in ascending order. Ascending order. Now you can see earlier you can see, buddy, this is a square of each element and the random. Now we arranged in a ascending order. Now maybe you have a doubt how do we can sort them into descending order. Right? Maybe you have a doubt, how to do in a descending order. Now there also, buddy, what you can do here is, I think you can call up to sorted as it is, up to sorted as it is. I mean, this code as it is, we can write it. But there, when you're calling sorted, you have to take the help of comparator. You have to take the help of comparator. And in comparator, you have a method called something, reverse order, reverse order. That method will returns, the elements in descending order. Okay. Now you can print the result 3. Now you can print, the result 3 so that, you'll get the output of, descending order, descending order. Let's run it and say this. Yeah, guys, you can see the elements are in reverse order. So again, if you see here, sorted is an intermediate operation. Yeah, collect is, terminal. It is preparing a final response for us. It is preparing a final response for us. And let me go with something, this distinct as well. Actually, what distinct will do is, let's say, let me take one more numbers. One more numbers. Let's say numbers 1. So what I was doing, I was trying to repeating the elements body like this. I was trying to, repeating the elements. Now what distinct will do is it will print only unique elements. Maybe in interviews also we got this question, I believe. How to eliminate duplicate elements. So then, buddy, the code is very simple. If you see here, just you need to call it distinct. So numbers dot stream, and you can call it directly method. The method name is distinct. Now what distinct will do is it will return only, unique elements from here. Okay. But where I have to store that? Then definitely again you have to take the help of terminal operation to store the final. Okay. Now let me take that result into a final variable. I mean a final result variable like this. And finally, if you print it, you can see only unique elements now. In the result 4, see if I have repeated so many elements, right? Now, if you see the output, you can see only unique elements. See, can able to see the unique elements, not duplicate. I hope you are clear this intermediate operations. Guys, clear this intermediate operation? Yeah. Thanks, guys, for the fast acknowledgement. Now, I'll show you the terminal operation. And one of the terminal operation, but we already discussed the first 2, I think we already discussed for each method. Today we discussed the beginning of the session. I think the first question today. And the collect just now I'm explaining. Collect just now showing. Now let me show you what is the count and reduce. Count and reduce, how to use the the count and reduce. Let's say, buddy, you want to know how many elements are there in collection. How many elements are there in the collections? This collection. Okay, and yeah, the numbers 1, how many elements are there? Just you want to know. Then directly you can call stream dot. There is a directly method is there. The method name is count, and it will return a variable called long count, and you can print. You can print it. Yeah. So let's run and check the count. Now, but you can see totally 19 elements are there because some elements are very repeated. Now, why it is called as terminal operation? Yeah, they are already terminal operations. Terminal operations are the operation they can use at the end, and they will prepare the final response. The first terminal operation I have shown you count, and just now we finished collect. The collect will prepare the final result. Count also will preparing the final response body on the numbers. Yeah, you can see the final load, right? And also there's one more is the reduce. I think reduce I have discussed in the episode 1. Maybe I'll show it again. I want to print sum of this all elements. Okay. I mean, I want to reduce the whole collection into a single element. Then how to use a reduce? Then I have to use reduce. So you can say numbers 1 dot. You can do stream dot reduce. Yeah, you have to take two numbers here, n1 comma n2, n1 comma n2, and that will return something, n1 plus n2. But this will here what reduce will do, reducing will the addition of doing all numbers, but still we are not storing this is into a result, right? We are not storing into a result. Sorry, yeah. If you call to Alt Shift L, hmm, it will get a final result. It will get optional result. And but if you call dot get method, you will get a final integer object actually. You'll get a final integer object. Do Alt Shift L. Yeah, you'll get a final integer object. You'll get a final integer object. That will return the addition of this 19 numbers. Addition of the 1990 numbers. Let's run it, and you can see 125 is the answer. So that's what few of intermediate and terminal operations. So does that make sense, guys? Does that make sense? Okay, good. And there are three more questions are there. So can I continue more for 10 minutes so that I'll wind up this? Guys, will you be there? Can I take more 10 minutes? Okay, fine. Right, right. So let's say, buddy, the datetime API. I'm not sure in core Java, you get a chance to work with some date and any calendar related classes. But in Java 8, they given some new classes. They given some new classes in datetime API. Okay. Now, if you want to see what are the classes, so if you see the classes are something, actually this date and calendar are before Java 8 they exist. Legacy means they already exist in before Java 8, date class and calendar class from Java 8 package. But in Java 8, other than this, they introduce some classes, but you can see local date, local time, local date time, zone date time, duration, period. Okay, these classes, buddy, and date time formatter. These classes they introduce as part of datetime API. I know it's very difficult to you as a fresher to remember all these class names, but few things you can remember is like local date, local time. Few things definitely can remember that. I have some examples to you to show you quickly. What are datetime APIs? I have I'll quickly show you them. Now, can you see this here? They are all from the package. If you see java.time, guys, they are given in a package called java.time, and java.time introduced in Java 8. Line number 13, if you see what I was doing, local time dot now. I think you can guess the output of this directly. It will return the current time. It will return the current time. You can print the current time and you can see this. Let me print like this current time. And buddy, if you see local date dot now, and I'm pretty sure you can guess that output by calling that method itself. You can see today date. You can see today date. And here also if you see current date and time, and here but you can see the complete with the time zone also you can see with time zone also you can see this. Remember at least these three classes. Okay, I know it's very difficult to remember all, but remember at least these three classes: local time, local date time. See, it's a combination of both. Local time will return only time, local date will return only date, local date and time will return both. These classes are not there before Java 8. Okay, before Java 8. Guys, can you see current time? If you see full time, you can see the full time. Only time you can see. And date, but if you see, you can see only date. And if you want to see the both, yeah, you can access current date and time class. So you can see able to date and as well as you can see the time as well. You can able to see the time as well. Okay, that's what how to get current date and time. And also I have one more example. I have one more example. Don't go to the code. Don't go to the code. Can you see in here, buddy? I have a one method. I have some method, some starting method, ABC method. I have a something, some ABC method. Inside it, I was printing some hello. Inside it, I was printing something, hello. But the factorial of code, right? What I'll do is I don't have a much time to write the factorial of a code now. So what I'll do is I'll take the code from the Google. 1 second. Because I want to show you this practically. Factorial programming in Java. Let me take any code. Let me take any code. Yeah, this is a code. This is just a code. This is just a code. Let me paste into here inside this method. Inside this method. So what this method is doing, if you see here, yeah, what this method is doing, do Control A, Control Shift F. So this method is doing, yeah, buddy, you taken a number 5, right? So it is calculating 5 factorial, right? It's calculating 5 factorial. Let's say, buddy, you given a number is something, 500. Just imagine, buddy, 500 factorial, 500 into 499 into 498. Lot of time it will take, right? Lot of time it will take, right? Now, if you want to know how much time it is taking, yeah, then, buddy, you have to take the class name is something, instant and the duration classes. They are also from java.time. See, the classes are instant and duration. Now, what first instant will do? It will take the beginning time. And buddy, in between, I'm calling a ABC method. The ABC method is doing the factorial. And we don't know how much time it will take. Okay. And finally, buddy, what you're doing? After completion of your ABC method, we are calculating again a time. So we got a start time, we got a finish time. And when you call duration dot between, when you call duration, duration is a class between. And if you give starting time and if you give the finish time, and buddy, you will get, the time in milliseconds, buddy, how much time it is taking. Let's run the code. I was expecting some exception, maybe 500 factorial. Let's say, buddy, it is taking, 10 milliseconds. See? Yeah, we got, I don't know why it is getting 0. Sorry. 1 second. Let me check. Fact equal to factorial of a number. 1 second. Let me find the factorial of 5. It's getting 120. Let's say something, 78 factorial. I don't know why it's getting, no, let's say 22 factorial. I think, buddy, taking integer, right? Integer will take, very less number of elements. Yeah, maybe guys, you can see 22 factorial. It is taking the time, and maybe let me change this to something, long. Yeah, long data types, long data types, maybe. Now it will work. Yeah, guys, can you see 22 factorial? We are able to found it. But if you see the total time is, yeah, here you can see 9 milliseconds it has taken. So this class also belongs to your date time API. Maybe it's not hard to you to remember. The first example, you can remember local time, local date, and local date time. And here in this example, you can remember, duration and instant. Duration and instant. So they use it to calculate how much time it has taken for your program. Also have one more example, buddy. So it will show you. Let's say I want to know your how many. What is your what is your age? If you want to calculate your age, then definitely, buddy, today date minus, you have to calculate your date of birth. Like that, buddy, we have a class called something, here. Here we have a class called something, chrono in it. Chrono in it. What it will do is it will calculate the date between. See, I have given a date one is now, and plus 99 days. Plus 99 days as in a date two. Now, if you want to see the difference between the two dates, yeah, now definitely you can see the difference, buddy. So totally 99 days is the difference. 99 days is the difference. So maybe you can remember at least this 4 as part of, date time API, buddy. At least you can remember 5 classes like local date, local date time, and instant, and duration. Maybe you can remember at least, the 5 classes. That's all about, your date time API. Also, but if you see the topic method references, and this is little bit tricky, but before that, I want to go with this basic example to understand what is method references. Maybe I'll take a basic example first, quickly. Guys, so far, I think, in a class, we can write instance method, right? We can write instance methods and as well as static methods. Static methods should start with static keyword, right? Static keyword. And instance methods will not have the static keyword. That's, the basic understanding of static and non-static. And instance method accessed by creating the object, like you have to create an object like this. And then you have to call ob dot that instance method name, correct? Guys, like this. So how you are calling this M1 method? How you are calling M1 method? Dot ob. Dot ob. Why it is a ob before the dot? Because it's an instance method. Before the dot, if you say an object, so it is an instance method. But before the dot, if you see a class, then it is a static method, right? I think this is, right? If any method, if you call before the method, I mean, before the dot, if you see left side object, then it is an instance method. And the dot left side, if you see a class name, then it is a static method, correct? Guys, do you know this? I mean, hope you remember this. Hello? Guys, do you remember this? The difference between static and instance methods? Okay. See, we know the
Sir, can you repeat again, sir?
yeah. I want to repeat something, here. Uh, in a class, you can add only two types of methods: instance methods and static methods. Instance and static methods. If method is instance, nothing but without static keyword, then that is accessed by the current class object. Current class object. And if it is a static method, it should be accessed by the class name. It should be accessed by the class name. Are you clear now?
Yes, sir.
Okay. Now the topic method reference is, it's completely new to you, buddy. It's completely new to you. Maybe I can show you one example first. Maybe I can show you the example first. So I was creating one list, buddy. I was creating one list here. This is my list. This is my list. This is my list. This is my list. Okay, this is my list. Yeah, if you want to iterate this list, today we learn in the beginning of the session, you can use for each method, right? For each, and each element will come an argument. Each element will come an argument. Uh, and here, buddy, you can write something, here you can write now SOP of, you can write that element. You can write this element. Guys, I was highlighting something. Can anyone tell me what is it? The beginning of the session, I have explained. What is it? I told you for each method will take argument as one functional interface. What is a functional interface name? Can you remember what is a functional interface name which is being an argument of for each method? Okay, that's all. No problem, buddy. Even if you won't remember, that the name is consumer interface. And at least you remember, I have written the code here is lambda expression, correct? Guys, I have written the code, lambda expression, right? Now this lambda expression, we can rewrite. I was commenting that, okay? This lambda expression, we can rewrite by using method references concept. We can rewrite now. Nobody, I was rewriting this code. The lambda, this is a lambda expression, right? This you can rewrite by using system dot out dot double colon. You can write println. You can write, println. So the advantage of, method reference is it allow you to call your lambda expression methods in a simple way. See, yeah, buddy, if you run this code also, you're going to be get the same output. You're going to be get the same output. See how you will get using for each method. Here also, buddy, you're going to be getting the same output. Now, definitely you should know, sir, how it is working. This double colon, how it is working. That is actually the topic of method references. Now, I'll show you how it will work. Now I'll show you how it will work. So I have taken one example here. If you see, the example is, first I have taken one interface. First I have taken an interface, and which has only one abstract method, single abstract method. The method name is check single digit, checking single digit. So what this method will do is it will take one argument and return some Boolean value. And we haven't implemented the code for this. We haven't implemented the code for this. Okay. This method will take the argument as one number and return some Boolean value. Now, there's a one class I have taken. The class name is digit with a one method called something, is single digit. And buddy, I think you know this code. The code is not tough. See, if your number is in between this two range, like less than 10 and greater than or equal to minus 10, less than 10 and greater than or equal to minus 10, then definitely whatever that number is there, then, that is single digit number, right? Minus 9, minus 8, and 0, 1, 2, 3, 4 up to 9, all are single digit number. I think you're clear with this logic. I believe you are clear with the logic. First, what I'll do, buddy, I'll explain you how to do by using, the lambda expression. First, let me write, the lambda expression, how to write this implementation by using, lambda expressions, lambda expression. I hope you remember you how to write first interface name, then object, then object, then this. I hope you remember the symbols, parenthesis and arrow and flower basis. PF shortcut, But I was writing the logic for this. It has a single parameter, right? X, and yeah, you have to write the logic here. You have to write the logic here is the logic will be return. Yeah, but I was returning this logic one. I was returning only this logic only. And we know, right? If it is a single and return statement, flower bases are optional, and return keyword is also optional. The single parameter, then the parenthesis is also optional. I think everyone know this code. Now, if I call ob dot, guys, carefully observe. If I call ob dot check single digit, or let's say, buddy, if I pass something, 5, then definitely it return true, correct? Then definitely it return true. Let's run it. And guys, see, it's returning true. Now, focus, guys. It's a starting method, no? One more class. Guys, there is no relationship between this interface and this class. Now, this starting method we can call by using this class name. The starting method we can call by using this class name, right? So we can call digit dot is single digit, and let me pass a number, same number, let me pass something, 5, or let's say pass 6. And here also, buddy, it returned true. See, here also it returned true. Here also going to be, it is returning true. Up to here clear? Or do you have any doubts? Guys, up to here clear? Just confirm in the chat. Up to here clear? Okay, fine. Now let's see the topic, method references. Now let's, the topic is, method references. Now, can you tell me this logic and, this logic you written for a functional interface, right? This implementation you written for this method. I want to repeat this. This logic you written for this method, but this logic is already written inside another class. The class name is digit and the method name is single digit. Do you understand this? Yes, do you understand this term? Do you understand the explanation which I have given? We return this implementation for an abstract method, right? But this same logic is already written in a one static method. Are you clear up to here? Yes, up to here clear? Both logics are same, right? An interface implementation and the static method implementation, both are same. In that cases, what you can do, you can create one more object for the interface, but this time, we are not writing the new implementation. We are not writing again new implementation because this implementation is already in one of the static method. So what we can do here is directly we can call digit colon is single digit method directly we can call. Now what will happen? Guys, what will happen? Just forget about this code now. Now, what will happen? Whatever the logic is written for is single digit, the logic is going to be implementing of this check single digit method. And if you want to see the proof, just you can call ob1 dot is single digit of, sorry, the method name is something, the method name is check single digit, and you can pass the number. Okay, let me comment this everything now. Let's run it. I'll tell you what's happening here. The output is true. As you know what's happening here. This is a class and this is a starting. This is a class and this is the starting method and I already have some logic. And this is interface, functional interface, right? In functional interface, one abstract method is there. For abstract method, developer has to write the implementation logic. For abstract method, developer has to write the implementation logic. With method reference concept, you know what you are doing. The logic which is already written for one static method, the logic which is already written for one starting method, the logic we are giving, or we are bypassing, bypassing to the check single digit methods. We haven't written the logic for check single digit here. Developer hasn't written the method with the code already written for the e single digit method, but the code is borrowing to this check single digit. That's what happening in method reference. So method references concept will help us to make method code reusability, because if there is no method reference concept, again you have to write this logic. Again, you have to write the logic for the check single digit. But this logic, we reused it. We reused it for this functional interface. And that's all about your functional interfaces. You can implement in two ways, by using lambda expression or using method references. And in the previous example also, buddy, that is going to be happening. In the previous example also, that's happening internally. Okay, I hope this is clear to you. I think, yeah, you have somehow a theory, you can go through on it. And the last example I want to cover, buddy, the last question, map and flat. Map and flat. Before I want to jump into this, do you remember this code? Yeah. Guys, do you remember this code? What map is doing? What map is doing? It is modifying each element in your collection. Map modifying each element in the collection. So what it is doing? It is doing square of each element. Do you remember this? Do you remember this? Map. We discussed map earlier. Example. Map used to modifying each element in the collection. Do you remember this? Right. Right. But now what is a flat map will do is on high level. If you see the slides, can you see left side example? Guys, can you see the left side example? What map is doing? If you take a collection here, if you take a collection A, B, C, D, if you use a map, now what you are doing, buddy? Each string we are converting into uppercase. Each string we are converting into uppercase, correct? Each string we are converting into uppercase, right? Let me take into that example quickly. Let me take that into example quickly. Example 10, I'll show you. So example 10, I'll show you. Yeah. Now, if you see here, if you see here, I have taken two strings here. Now I was calling map dot. There's a method. Let me call something, to uppercase. With method reference concept, I was doing this. Now it will become string. No, it will become string now. No, it will become string now. Now, buddy, it will become something, all are, uppercase strings. All will become, uppercase strings. They will become, all are, uppercase strings. You given hello students, right? But hello students, buddy, you can see, in uppercases now. In uppercases. I think you are clear what the map is doing. Now, if you go to the slide, what map is doing, it is taking each string object and doing some transformation on top of it. Right? Now, let's talk about the flat map. What flat map will do, it will do the two works, buddy. It will do the two works. First, it will do transform. And then it will do something, flattering. It will do flattering. And I'm sure you don't know what is flattering. Okay. Can you see the example here? How many collections are there? How many collections are there? Can I get the answers from you guys? How many collections are there? One collection or collection of collections? One collection or collection of collections? Just say, one or two option, guys, in the chat. It's a collection or collection of collections? Yeah. But left side, only collection of strings. Right? Left side, if you see, only collection of strings. But right side, if you see, collection of collections. 4 collections are there. Now I want to perform some operation on this collection of collections. Collection of collection. Then you have to go with flat map. That's the only difference between map and the flat map. Map will do some kind of transformation on only collection. Map will do transformation on only single collection. Whereas flat map, what it will do is it will do transformation on collection of collections. Now this is output body. Now if you see 1, 2, 3, 4, 5, 6, 7, 8, all are belongs to 4 collections. Right? Now what flat map will do, it convert into a single string. Now that example also there here. That example also there here. So I have taken one more example here. Now guys, if you see, I have taken 1, 2, 3, 4, 5, 6, 7, 8, 9 as 3 collections. This is a collection 1, collection 2, and collection. So what flat map is doing here is, what this flat map is doing here is, it is converting your collection of collections into a single string. See, it's collection of collected into single string. Now on the output body, if you see, you can see all as single elements. You can see all are single elements. You can see this. That's all the difference between flat map and map. Are you clear? Guys, are you clear the difference between map and the flat map? Okay, cool. And maybe in the next week also, buddy, I was planning some more episode questions. So on high level. So today we have discussed, this 7 question answers, buddy. Okay, I'll show you the first slide. Just give me a moment. Yeah, these are, the 7 question answers we discussed. The first one we discussed today, difference between for each and a for each loop, for each method, and then optional class methods for null check. Stream API, intermediate and terminate operators. And before Stream API, I have shown you with collection the complexity of doing the operations. And datetime API and method references concept with double equal to how to call it, I mean double colon. And last question I discussed map and flat map. In the next episode also, buddy, I was planning some basic interview questions, maybe not in a completely high level. Maybe I'll go with some basic level and OOPS concepts and all. Okay, and that will definitely help you more in interviews as well. Okay, that's all for today. Yeah, thanks guys. Bye. Good night, everybody.